Space group of a crystal. The arrangement of atom of a three-dimensional crystal can be determined by knowing the point group. We know the arrangement of atom around a lattice point. Two identical-looking crystals have different properties. The point group are the same, but they have different properties. This due to different space group. Symmetry element had been discussed, which are plane symmetry, mirror rotation symmetry, rotor inversion, rotor reflector symmetry inversion. In this presentation, we will be discussing on glide plane and screw axis. Screw axes are the symmetry elements which describe helical symmetry. Two-fold screw axis, at point 1, A will produce B prime due to two-fold rotor, then translate to B. The process of two-fold rotor and translate. At point 2, A will produce B. At point 3, A will produce B. Three-fold screw axis. A screw axis rotates at the same time translate along it. Amount of translation is 1/3 of parameter. The location of point 1, 2 and 3, A would have produced a point B, but since it is a three-fold screw axis, instead of B prime, it produced B, and instead of produce C prime, it produced on third up. Glide plane. Glide plane consists of reflection and translation. At point A, B, C, D, they are lattice point. Point P translate along this line and reflected to Q. Glide planes is a combination of a reflection and a translation parallel to the reflection plane. The translational component can be half of the translation unit, which are planes A, B, C, and E, or a quarter, which is plane D, always in a parallel direction to the plane. Space group P2. Lattice has two-fold rotor through this lattice point along y direction. Then at each lattice point, the given group of atom will generate another group of atom. It is at different level, written as O-. Similarly at other lattice points. This two-fold rotor not consciously used, but it come to existence because of the arrangement of the group of atoms that are possible after rotation around two-fold rotor along the y-axis. So this new fold axis that is generated. There will be space group rotation at two-fold screw axis along the Y. Screw axis rotate at the same time, translate along itself. Group of atoms attached to the lattice point will produce another group at 180-degree rotation, but at the same time, it translates by half a lattice parameter along the Y direction. Similarly, the group attached to the other lattice point will produce another group at 180-degree and translate. Both P2 and P21 have the same lattice point attached, but since lattice two-fold rotor 18 on the lattice point and the lattice has A two-fold screw axis 18 on the lattice point, the arrangement of the group of atoms through space is quite different.
The next example is the C-type lattice. It is a two-fold rotor along y-axis. This group of atom will produce a similar group of atom at 180 degree away. The O positive will give a O negative. The arrangement of O negative, O positive and O negative as if there is two-fold screw axis passing along the line at the bottom and dotted line. The group of atom O positive, O negative and O positive as if there is a fold screw axis passing through an upper dot line. For space group PM, it is a primitive type with a mirror passing through the lattice point. Due to the mirror, it will produce a group of atom by reflection. O positive will produce another O positive side by side. When there are given mirror on left and right side, a new mirror is generated. In conclusion, point groups will help us to understand how atoms or group of atoms are arranged at a lattice point. The space group will provide us a sense of how the atom groups are arranged over the crystal's extended volume.